Hello friends, welcome to Eastern Academy. We are discussing about Microprocessor. This is session 6. This is part of our embedded system programming course. And today we are discussing about memory map. The last session we discussed memory map, the top level, and now we get into the deep into the thing. What is that? And as I told you that as an embedded engineer, you should know two things. One is C programming. Next one is memory map. These two are sufficient. You have to, as an embedded system programmer, you should know C programming and memory map. That's enough. We will discuss about that, why I'm telling that. So let us start with a very simple example. In your school, your teacher asked you to bring a notebook. She said that bring 100-page notebook. 100-page notebook. So you have a 100-page notebook now. And 1 to 100. When the teacher says that, open page number 20. Open page number 20 and write. Then you will write. Then the teacher told you that open page number 40, right? You have written on page number 40. Am I right? You have so many pages. Any page you can, if the teacher tells you that open 90th page, you will open 90. If a teacher says open 100th page, you will open. If a teacher tells you open first page, you can write open. So if a teacher tells you that whichever page, then let's say the teacher tells you that open page 50 and read. Then you start reading. You open at page number 50, you go to the 50th page and start reading. Then teacher tells you that go to the page number 60 and write. Then page number 60, you will write whatever the teacher is telling. Am I right? This is very, very simple. That's a simple concept. Teacher tells you that read or write. And if you read something on the page, teacher will listen. If you want to write, teacher will tell you. That's it. Now, the teacher asked you one important thing. Then only she found out that when you write on English, that has to be ruled. If you do maths, that has to be plain. So, on a ruled notebook, when you do the mathematics, it does not work. So, teachers told you that bring a notebook. The first 50 page, 1 to 50, should be ruled. That is for English. And page 51 to 100 to be plain. Understand? There are two notebooks. One is ruled is 1 to 150, the English and everything. Now it's a trick. Your father went for market to bookstore. They said they don't have a book like this. So your father did a very good one. Your father bought 2 books. Your father bought 2 notebooks. $50 this is a 50 page, this is a 50 page. Understand? Both are 50 page. This 50 page is 1 to 50. This is 1 to 50. But what your father did was, he stitched both together. Stitched. Now this becomes a 1 notebook. This 2 becomes 1 notebook of 100 page. This each one is 50. But now after stitching, it become 100 notebook. Actually, this is 1 to 50 on 1 to 50. But from this side, After stitching, it became 1 to 50, 51 to 100. You can stitch any number of notebooks, doesn't matter. So your teacher will ask you to write English. I say that when a teacher is taking the English class, the teacher says, hey, go to page number 35, write. Whatever I say, hello, welcome to school, or whatever it is, you write it. Page number 35. Sorry, it's not possible because you do only English. So that you read. You cannot, in the rule notebook, you cannot do math. So if an English teacher comes English, he will say 1 to 50. When they do maths, the maths teacher will use from 51 to 100. Understand? So you have two notebooks you stitched. And English teacher will use 1 to 50 and math teacher will use from 51 to 100. The two functions now. Both are in single notebook. Now the same thing happened here. Now the same thing happened here. I'll tell you how it happened. This microprocessor gives 6 address lines. And that is from 0, 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1, 1. That is 0 to 63. That is 0 to 63. Now I have two notebooks. I have two notebooks or two memories. One is ROM, one is RAM. I have two memories. Okay. This memory is 32 lines. So 0 to 31. This one is 32 to 63. Is it clear? Sorry. This is also 0 to 31. Sorry. Both are 0 to 31. Let me write here. 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1. Binary. 0 to 31. 0 to 31. Now, how I'm going to stitch? The stitching is a technology. You need to understand. For this guy, see here, there is a barrier. The microprocessor don't see it's a ROM or RAM. The microprocessor sees only 2 power 6 is 64. 0 to 63. But the two physical chip, they're all two physical chip. This is a separate chip. This is a separate chip. Okay, like a notebook. Two separate notebook. Your father stitched. Like that, we are going to stitch. That is what the job of our hardware engineer. How he is stitching. That's a trick. The beauty is, this guy is having how many bytes? 32 bytes. So, this guy had how many wires? 5. This guy had only 5 wires. Now, this guy is 6 wires. A0 to A5. Am I right? That is actually, you can draw like this. A0. Let me expand it. Then it'll be easy for you. I expand it. Since initially we are discussing A0, A1, A2, A3, A4, A5. But this guy has only 5 wires. A0, A1, A2, A3, A4. This guy is having 5 wires. A0, A1, A2, A3, A4. What the engineer did was, very beautifully the engineer did. He connected this A0 to A0, A1 to A1, A2 to A2, A3 to A3, A4 to A4. Fine, done. All the 5 wires are connected. A5 is not connected because this guy only 5 wires. Then what he did was, another thing was very, very, very surprised. He connected the same A0, to RAM also. A1 to A1. See here, this looks to be very small confusion for you. All right. So I have 10 wires now. Now A5 is not connected this case also. Now if the microprocessor, when the moment you give a power 5 volt, the microprocessor gives address 000, what will happen now? 000, what will happen now? 6 zeros, because A0 to A5. What happened? This is not connected. These 5 zeros goes here also, goes there also. Now this is 0, this 0 will come out, this 0 will come out because he's going to read. He's going to read first. So what engineer did was very interesting thing here. That has been understood. I want this to be 0 to 31. This guy is 32 to 63. So when they give 000, this guy should not respond. Only this guy should respond. For that, the chip manufacturers had a signal called chip select. They have a signal called chip select. When you don't make this as a 5 volt, that is 1, the chip will not be selected. All the chips, all the chips manufactured by the companies, they have a wire called chip select. If you don't make it as a 1, that chip will not respond. Even though you give address, that chip will not respond. That give it keep white. So what they have done, they've taken the A5. See here, understand, they've taken the A5. See here, simple thing they did. Put the inverter and connect it here. And put the A5 directly here. Do you understand now what I have done now? What I have done? I just have a snap. I will redraw it once again. I'll redraw it very easy way. Then you will understand. So what we have done it here. I'll redraw it now. Then you will understand why we are writing it in the simplified way. Now I have a microprocessor which gives 6 address lines. I take 5, I divide into 5 and 1. Okay, I divide into 5 and 1. Okay, we'll see that. Let me that now I'll do that. Now I have 2 chips. ROM and RAM. Both has 5 address lines. I connected this. So when the microprocessor gives the address 0000, the first 5 will go to both. But they have a signal called chip select. Only when the CS is 1, the chip will be selected. If it is 0, the chip will not be selected. Okay. Now what we have done it is, we use this signal, we have put the inverter here. Connected. And this one, the bottom one, we connected directly. Now what happens now? See that now? When the microprocessor gives 0000000 on power on, when you give a 5 volt, this is A5. Now A5, this is A0 to A4. This is A5. Now A5 is 0 now. So this become 1. This chip is selected, but this is not selected because the 0 comes here. Suppose the microprocessor gives the address 32. 32 means 1000. Now A5 is 1. When A5 is 1, this will be 0. And this becomes 1. So this will be selected and this will not be selected. This is called stitching. I'm stitching both the chips. Now this becomes 0 to 31, 32 to 63. Let me write on binary. When you write on binary, you will know that. When you write on binary, you will know that. That's a problem now. Since 0, 0, 0, 0, 0, 0 to 0, 1, 1, 1, 1, 1. This is 0. This is 31. 1, 0, 0, 0, 0, 0 is 32. 1, 1, 1, 1, 1 is 63. See here, in this case, 0. When A5 is 0, when A5 is 0, this will be selected. When A5 is 1, this will be selected. So ROM now, for this guy, for the microprocessor, ROM is, I have 2 chips. ROM is starting address is 0 to 31. RAM is 32 to 63. This is called memory map. How my memory is mapped. For the microprocessor, 64 bytes. I map ROM and RAM. If you have any doubt, ask me now. That's very important. This is what this page you have to understand. If you don't understand the page, I'll explain to you once again. Let me know, but you should know where you don't understand. Whether microprocessor is 6-bit or memory is 5-bit, how I connect, you have any problem. This is all connected. Same wires.
Sir, I just have a clarification, sir. I just want to inform.
No, I
This
think
inverter, sir, can you hear me?
yeah, I'm hearing you. Yeah.
Sir, just want to clarify one more thing. So the inverter which you connected, sir, since earlier in the previous session you told that since all microprocessor in the world they first read data on, since they start reading data from the ROM. For that reason only we have converted the inverter to the ROM. Correct?
Yeah, the initial date. No, not like that. When it becomes 0, this has to be selected. The inverter only will make 0 to 1. That's the reason. All the microprocessor on power on have to read from ROM. That's the first instruction that is very important. You are right. Okay, now.
Okay.
Now I'll tell you. This once you understand that, I will tell you now how to simplify this. Don't worry about these things. Now the trick here is this. I've given an example now, 32 plus 32, 64. Now I'm telling you that I have a 64 byte. I have a microprocessor which has 16 address lines. Sorry, 6. I have a ROM of 16 bytes. I have a ROM of 16 bytes. Only 2. I give you only 2 clues. How do you connect? Am I right? I told you that the ROM is 16 bytes. Then I told you microprocessor. But since I said ROM, it has to always start from 0 to 50 because only 16 bytes. Understand? So 0 to 50. This guy gives the address of 0, 0, 0, 0 to 1, 1, 1, 1, 1, 1, 1. But this guy has only 0, 0, 0 to 1, 1, 1, 1. But as I told you that, since I told you a ROM, the first address has to go to ROM. So from 0, 0, 0, 0 up to 0, 0, 1, 1, 1 should go to ROM. Is it clear? This is 0, this is 15 because 0, 0, 1, 1, 1, 1. So this microprocessor can give address from 0, 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1, 1. Let me make it outside. Let me make the microprocessor small. I don't mind. So this microprocessor, which has 6 address lines, can be from 0000 to 111111. But we are mapping this ROM, the first 16 bytes. This is 0 to 63. We are mapping first 16 bytes. If you see here, you can divide it into 2. This is variable, this is fixed. 00 is not varying. Now what we have to do here is simple. I have a ROM which has 4 address lines because 16 bytes. 2 power 4 is 16. From here I take 4. I take 2. I connect a select logic. Or as I mentioned to you last class, it's a naming. This guy name is 00. You are giving 2 bytes. When it becomes 00, this becomes 1. We will discuss this in a combinational logic. This is nothing but, what is internal is nothing but, you have 2 wires you are giving, both are inverted, and we put an AND gate. That's what that inside. So the moment I give 00, this becomes 1. But if I give 0100, then what happened? This becomes 01. So this becomes 0, this becomes 0. This is not selected. The ROM will be selected only between 00 to 11. Is it clear? Like this, I can connect. For example, my ROM is 8 bytes. My ROM is 8 bytes. That means 3 wires. Then 3 will go here. My name will be 000. That means that this will be like this. 3 wires will go here. A5, A4, A3. When all are zeros, this becomes 1. So what we effectively, what I'm trying to say is that, please understand the wires are physical. You can have 1 wire or 2 wires or 3 wires or 4 wires. 1 wire means 2 power 1, 2 location. 2 wires means 2 square, 4 location. 2 power 3 means 8 location. 2 power 4 means 16. You will not get a memory of, that's why if you see a memory, you get 16G, 32G, 64G, 128G. Can you see that? Gigabyte. The memories cannot be, I cannot have a 5 byte. I cannot have a 7 byte. I cannot have a 12 byte. It will be always in the size of 2 power. Because the address lines are always physical numbers, 1, 2, 3 like that. So the memory addressing a location is based on 2 power. If I have about 8 wires, 2 power 8 is 256. So it will be like this: 2, 4, 8, 16, 32, 64 like that. You will never get memory of different size. So let us assume now case. This is the way it works. I'll tell you that this is a very simple way it works. Any microprocessor, I have a memory. If it is any memory, let us assume device. You can take any device. You can have any number of devices. It's a very, very simple math, man. Simple math. Please understand simple math. Try to practice this. Try to practice. I'll give you some. Try to practice. Whatever this guy is having, M number, and whatever you are giving here is N. And this N will be divided into 2 groups, M plus X, assuming. X will be used for naming logic or select logic. M plus X is equal to N, or you can say N is equal to M plus X. That's it. You can give any size. You can do this. That's right. Am I right? Is it clear? If you understand this, you understand the entire memory map. You can put the device anywhere. Let us say that I have a memory of so big. Let us take right now. Right now, let us assume that n is equal to 6, m is equal to 5. That means that I've given you that memory is 2 power 5, 32 bytes. The microprocessor is 6 bytes. So n is equal to 6, m is equal to 5. So x is equal to 1. Then 6, 5, and 1. 5 plus 1 is 6. The name, this is only 1. The name can be, since I have only 1, name can be 0 or 1. Let us assume if it is 0. If I give name as 0, understand? So what is happening is, when you write the n, it's xm. Why I write like this is what you are giving here the name. And this is the range. M is now 5, the case of 5 bits. So 0, 0, 0, 0, 2, 0, 1, 1, 1, 1, 1. So this address is 0 to 31. That means that your memory is going to occupy here. This is what your ROM address. Suppose if I change the name to 1, the block name, then what happened? This become 1. So the address starts from 32 to 63. So this goes bottom. So if I have a memory, I can put in top or bottom. Since I have a 32 bytes, 2 into 32 is 64. I can put the device in top or bottom. I can put anywhere as you wish. You can put anywhere. But only case is, if the device is ROM, special case, if a device is ROM, it has to be in the beginning. Because when you give the power to microprocessor, he starts from beginning. That's why we always say that ROM has to be in the beginning. That's the only, otherwise you connect any device anywhere you can put it. Now I'll tell you let us say that you try to solve this in 2 minutes. Then you will find out. I have a microprocessor with 8 wires. How many? 8 wires. I have a memory of 64 bytes. And this is RAM. You can connect anywhere as you wish. Now, I want the RAM. Let us say the RAM address is from 0 to 11111. Because this is what 8-bit. 0 to 255. Totally 256. And this guy is 64. I can work into 4 groups. Let us say this is 0 to 63. This is 64 to 127. 128 to 191. 192 to 255. Suppose I say that I want to place a ROM here. How do you connect? This is N, and that is M, and this is X. Chip select. If you tell me what is a M and X, you solve the first problem. What is M? What is X? You should find first M and X. N I told you. I didn't tell you M and X. Can you tell me M and X? Then we will see next one. First we will find out M and X. What is M? What is the value of M? What is the value of M? Please take your time. I will not give you the answers. I want somebody to give an answer. What is the value of yum? I told you, this is all very simple maths. But you need to understand. What if you don't understand yum, then ask me why you don't get it yum. Please. What is yum? What is x? You have to find that. So your rule is like this. First find yum and x. Then you should find the name. That's it. This is the rule. That's all. Then you find that you are done. This is the way you should find out. What is yum now? Because this is 64 bytes. 2 power 6 is. So the yum is 6. So yum is 6. M plus x is n. So n x is 2. So the name will have a x is 2. The name will be 2 bytes, 2 bits. There are 4 blocks. 0, 0, 0, 1, 1, 0, 1, 1. So this is 1, 0. That's it. That means that what is inside the block is, I write the inside the block. What is inside the block? This block. 1, 0. That's it. Connected. We are connected. This, please don't think there's something complicated. I know that. I know that this itself is complicated for you, but it will take some time for you to understand it. But understand it. There's nothing. Let's not go very hurry. I wanted to. This time I take even decided to take a few days extra. But I want you to thoroughly understand this memory map. I want you to thoroughly understand. There's nothing called you have to come back. Never. If you walk back a step, never try to come back. Make sure that you are strong in this. You should understand thoroughly the memory map. Any doubts? If you have any doubts, you can ask me now. I'm waiting for the doubts. Now let us take one more. Then let's see that how do you do that. Let's take. I have a microprocessor which has 10 address lines. That means 2 power 10 is 1024 bytes. 1K. I have a memory of 256 bytes. Oh, sorry. 128 bytes. I have a memory of 128 bytes. And I say that this is ROM. This is ROM. I given a clue. Now I want you to connect this. How do you connect? So let me make it slightly above, then easy for us. This guy is having a chip select. This guy is having a address line of M, and this is your select logic. And this is M. This is X. Now, what is M? What is X? That's first you should find out that. When you find M and X, then you can find the other ones. And you should always say that what is the starting address and what is the ending address. That is what the trick. That's what we ask. And if you understand that, you understand the umbrella. As I told you that I don't mind to spend even one more day for this, but this has to be thoroughly understood by you. Yeah, perfect. Now M is 7, X is 3. Since it's 3, the name will be 3 bits because it's 3. That match. Now tell me what is the value of 3 bits? X. What is the name of this box? Every box, I told you, all the select logic has a name. What is the name of this box? 0, 0, 0, because it is ROM. When I say ROM, the x-axis is 0, 0, 0, 0. So the name is, that's it. That's it. You've done. You've done. Now, how do you write this in a binary? That's a trick. This is 0, 0, 0 right here first. That is, you write the name first. Then you have a 7 bits. So 7 zeros. Starting address. And 0, 0, 0 ending address is 1, 1, 1, 1. So 7 bit biggest number, 7 bit smallest number. So if you take them into 4, 4, 4, 0, 0, 0, ending address is 0, 7, F. In your memory map, starting address is 0, 0, 7, F. It's clear. Now, I slightly confuse you now. I slightly confuse you now. On the same system, I want to connect a RAM. I want to connect a RAM. The RAM also 128 bytes. The RAM also 128 bytes. The same 10 is going here. The same 10 wires is going there to RAM also. RAM is also having M. And both are 128. Now M is 7. We know that. Then I have a same way I take the X. And X is equal to 3 now. So X. Now tell me, what is the X now in this case? The case of RAM. Tell me X. Yeah, it can be anything. It can be anything other than 0 because already we allocated 0 to this guy. 0, 0 is allocated. I cannot allocate the same byte for this guy also. There are 8 combinations from 0, 0, 0 to 1, 1, 1. This is allocated for this guy. Now I can take anything. Let us say we take 0, 0, 1. Now we find out that what is the address of RAM. So 0, 0, 1. Then how many zeros? 7 zeros because 7 bit. M is 7. Then end address is 0, 0, 1, 1, 1, 1. So if you divide them into 4, 4. 0, 8, 0. Then the end address is 0, F. This is called memory map. These are all unused. End is actually what happened. This is 2 power 10. 2 power 10 is 10 ones. That means 3 F. These are all unused. From 100 to 3FF is unused. We use only this ROM and RAM. But RAM can be anywhere. Need not be only here. If you put the change XXX different, the RAM will change. ROM is the only thing it has to be in the beginning. RAM can be anywhere. It does not be. I have given a 2 example. I have given 2 devices. You can connect any number of devices. You can connect any number of things. That's a trick. I will show you something. It may be very big confusion for you, but if you very surprisingly do that, it is not that much confusion. I'll show you a very big one. Let me take it directly to the ARM 32-bit. I'll show you the small example because you may be slightly confused. That's why I say that. I go to the ROM directly. Okay. Let's go to the data sheets. Let us take directly a ROM that this one, very complicated processor of this guy, ARM processor. We will discuss this later, but anyway, I want to show you that how they have done it. Then you will understand that how you are going to read that. Okay, that's a trick. Here, correct. It's one of the very good processor. You know that. Very powerful processor. ST Micro's 32-bit ARM processor. Now let us go here. Introduction. Okay. See that this is, you will get confused this. I know that. Since you're just starting, but I'll make sure that you understand this thoroughly. At the end of the class, you'll be understanding this thoroughly. Please understand. See here. If you see this block diagram, you don't understand anything. See that so many things are connected. And you know one thing, what we are discussing microprocessor, it is this. Such a small one. Okay. See here, what you see this block. ARM, not the whole one, sorry. Sorry, this guy is showing everything. Okay, ARM Cortex M4, 168 megahertz FPU. This is a CPU which you are discussing. This is the whole chip. The whole chip, what you are seeing now, such a big. I can make it even zoom a little bit small, so you will know that. See here, still small. See here, this is so, I don't know whether you can see it on mobile. This is so complicated. I'll expand it now. When I keep expanding, this is what we are discussing now. D bus, I bus, and S bus, and all this address bus, data bus, and everything. Forget about that. We'll discuss more about this later. But you will thoroughly understand this. I'll make sure that to understand you thoroughly this. Now, this case is having so many blocks. each device, they had a ROM. See here, if you go up, they have a ROM. This is called flash. They call flash as a ROM. See, they have a ROM. They say that it is 1 MB. They have a RAM. And they have so many other devices, n number of devices. Timer, I2C, CAN, SPY, UART, everything, ADC, DSC, temperature sensors, RTC, and GPIO. There's so many things are there. The moment you see this, you will be complicated. Okay, but think 1 minute. How such a small country of Britain could conquer India? That's actually called divide and conquer. That is what we are going to do. Now, what they have done is, they have made this into the small blocks, and they have given you the, for every block, they give an address. That's a name. Every block is having a name. I'm sorry, I'll make it smaller. Don't worry about it. This is all quite simple. They're not, maybe right now you are saying that you will be finding it tough. See here, there's a session called memory mapping, fourth chapter. This is what, see here, what they have written here. From 0002, let me make it big. See here, from starting 0002 all the way to FFFF. They have given you that who is going to occupy your place. Oh, this is going to be occupied by code, ROM. This is going to be occupied by SRAM. This is going to be occupied by peripherals. What is that? Now, if you go right, see, they have given you this. I'll make it small. No, don't get confused. I'm telling you once again, I want to show you that how the people will tell you that memory map. If you take the other processor, let's take the other processor. It's a very simple one. Your Arduino one, which is a small processor. They use it as a what chip? 328P. Take the data sheet. Okay. They also have a AVR memories. They have a memory map. So they have a registers description. Let's go to the bottom. You see that, then you will see the thing. See, they will tell you that what which address, what device is there. See that address. This is what you're going to use. Left side, you see that. So what I'm trying to effectively say is that don't get, these are all the way they give you. They give you the block diagram, features, and block diagrams. And this we will discuss in coming days. I'll take a data sheet and see that this is such a small, see, compare the difference between this ARM processor, which has how powerful it is, the amount of blocks inside the chip, the amount of blocks inside the chip. See here. See that now? How many blocks are inside? Okay, but whereas compared to the your Atmega Arduino board, see that CPU, and they have a very small blocks, about 3 ports and a few timers, analog and everything, SPY and all. And this is what you need to know, that how each one is having the address map, how they are connected. See here, they given a memory map. 0002 3FF, there is a program memory. Each memory, they will tell you that what is the block. So forget about now, we'll go back to the table. why I've shown you is that is a way all the chip manufacturer will tell you. If you don't know what is the address, you cannot access. Now let us assume that. I make a chip. I make a microprocessor. I have so many devices. And I'm having 6-bit address, assuming. And this guy is from 00 to 10. 0F. That is 16 bytes. This guy is 10 to 1F. That is another 16 bytes. Okay, this guy is from 20 to 3F. 16 bytes. Okay. We have 32 bytes. I've written in hexadecimal. Please practice coming days. From today to Thursday, Friday. Watch the number system videos and make sure that you get it. This is, if I write on decimal, 0, 15, 16, 31, 32, 63. Am I right? This is what we do that. Now, if I write a program now, char star x, x is equal to 32, star x is equal to 25. Now, since I given 32, the 32 match here, this 25 will be written here. If I say the same thing 31 and star x is equal to 12, this is 31, 12 will be written here. If I written here 15 and 10, 10 will be written here at 15. I can also write the same thing like this, 0x f 10. I can return here as a 1f, 12 is written. I can return this as a 32, 20. I can return 25. So please understand, you can write on any chip, any value using your microprocessor, using your C program. We will connect more devices on Friday. Because if you don't understand this, you cannot understand microcontroller. Please understand. To understand microcontroller, you need to know this. Microprocessor, multiple devices, device 1, device 2, device 3. How we are connecting. Once you learn how to connect all of them, then you learn microcontroller. Once you learn microcontroller, you can start doing the embedded system programming. That we will do it on coming session, that is on Friday session. So you'll be thoroughly understand on Friday about microcontroller once you done this. I don't want to push that. I may delay this even one more day on Saturday or Sunday also. But I want every one of you should be 100% perfect in memory map. 100%. If I give you any sheet, ARM or Arduino or anything, you should be able to understand thoroughly. Without that, don't proceed further. I know that I told you now, in C programming, we have a block at loop. If you understand loop, you do it. Then understand functions. Like that, here memory map. If you don't understand memory map, you will act to everybody that you understand things, but you don't really. If you don't understand, you cannot be a good in embedded system programming, please. These two are absolutely related. That's why I'm spending, even I take this time more than 2. Last time I took only 1 class. This time I'm taking more class. It's because I want you to thoroughly understand the memory map. Okay, even I don't mind to discuss on Friday or full also this, but please, you also put the effort during this next 2 days, Wednesday and Thursday. Make sure that you watch the video and try to understand this very thoroughly. Okay, you yourself connect various devices and try. If you want, I can send you the problems. You can ask me. You can just ping me. I will send you the problems for you, memory map problems. I don't want to send everybody. I don't not to confuse people. Those who want, I'll give a problem. Okay, I'll give you a problem. Solve it very thoroughly. Have to have 100% thorough on memory map. Otherwise, it does not work. Nothing will work. This is very important for embedded system architecture and computer architecture. It's very important. Okay. Any doubts?